Cool. So, I guess today's lesson, I'll try to shed some light on DevOps and also how DevOps is tied into AWS, which is Amazon Web Services. So, this picture here is pretty much, I had explained this. I actually was explaining to Kojo while just freestyling and just ended up getting this diagram in order to just like give the flow chart or like the processes or the steps that are related to DevOps. Well, DevOps, like you guys know, is like agile form of IT, the way you try to sync both the development team, which is the guys who do the coding and so, and the operations team, which are the guys who actually keep the stuff up and running, maintenance, troubleshooting. But now, well, not now, it's been a while, but most regular software development companies are choosing DevOps because previously they used to use waterfall, and waterfall is when the development people do the development, they wait, pass it on to the testing team. When everything checks out with them, then they'll pass it on to like operations team for them to deploy it to um, production environment. But now with DevOps, everything is done hand in hand, and pretty much the keyword in DevOps is automation, like automating all these manual processes that they used to do in the waterfall scheme. So, um, firstly, I'll try to compare what was done before than what is being done in DevOps now. So, previously, most developers will just develop on their personal computers. Then, when everyone is done, they try to all sync it together to get the final product going. And along the line, methodology called source code repo or repository came about where um, most companies wanted to collaborate the coding just to like provide some type of transparency. So that's where Git and GitLab came about. These are like the OGs, the originals. Then along the line, other source code repo companies came along like Bitbucket and GitLab CI and so forth. But then Git and GitLab are the most famous, um, I guess, version control code repo. So with this one, um, all developers, um, we have two types of things when it comes to source code repo. You have something called your remote repo, which is, for example, if I went to like um, GitLab.com, this would be the remote. Not even GitLab. I'll do GitHub. Yeah, GitHub is the more famous one. So GitHub is the remote code repo. So all developers or your teams, you push all your code to GitHub, and you have um, a local type on your computer called Git. So that's the difference. The Git is the one that you have locally on your computer, and GitHub is the remote repo. So what they do is they do their development on Git. Git is like you can do it through a GUI or command line. You do your development on Git, then you push it from Git to GitHub. So that's where the collaboration comes in play here. Everybody does their coding, push it to GitHub, and you know everybody it provides transparency because you know who like added new code to it, who changed something and all that stuff. So it just provides transparency. If something goes wrong, you can like kind of track a timeline to see whose code might have messed up something. So that's where the first part of DevOps come, which is the collaboration of code by the a team of developers. So before the when GitHub came about, when it was done, testers still had to go into GitHub and grab the code from there and do their testing, which is still kind of waterfall. So in DevOps, introduce what you call automatic building and testing. So with this one, we use a software called Jenkins. Jenkins is the most famous, I guess, CI continuous integration, continuous deployment. That's what CI/CD means, integration and deployment. So with Jenkins, I'm just kind of just opening your website just to lay some light on like what your interface looks like. I'm not actually downloading nothing. So Jenkins is the most famous CI/CD tool. So with that one, it provides a framework for you to kind of have everything in one place in terms of building and testing. So it's its own framework, and it has stuff known as plugins. So the plugins help you like install building software on top of testings as well as deployment. So with the plugins, it's kind of like add-ons. Like you know how for example, I'm using what Google Chrome browser. They have stuff like plugins or extensions. Yeah, that's a great word. So the extensions, here I have like a I didn't even mean to start that. I have a Binance wallet, which is like some type of crypto stuff. I have a McAfee antivirus extension. I have a MetaMask. You can keep adding extensions to your Google Chrome browser to fit whatever need that you have. So that's pretty much kind of how Jenkins is. You're adding the extensions, and you call that plugins, and you add these extensions depending on what you need. So to to go ahead with automatic building, previously, when that's how these developers did, after they're done coding, they have to build whatever build or compile whatever code that they did, whether in Java, C plus, Python, whatever. You first have to code it, then compile it to make sure it runs. And usually they did that manually. So with Jenkins, you can install a plugin called Gradle or Maven. These are like build automatic building and testing plugins. So with that one, you have to actually write a code. So DevOps is all about coding. So you have to use the code to automate whatever manual tasks that you have. So you build a code using Maven or Gradle. Then inside the build, so you have something called build scripts. So I'm just gonna be googling stuff. So for example, Gradle build script, because there's always examples of stuff everywhere. So if I even click on this first one, let me see. So here's an execution of a build script. So the build scripts are coded in a way that you've already declared what you want to happen, like what you want the code to do, like how you want it built. You declare it as code. Then after it's built, you want to test it. We have something known as unit testing and functional testing in software development. You want to make sure it works in its own individual units that are in the code, as well as the function the whole code comes together to do. So unit and functional testing. So with that one, you can also use Gradle as well, or Maven to do the unit testing. But then to do that, you have to code them in a way that it pulls. We have something called SCM polling. So what SCM polling means is that each time that somebody from the software development team commits code to the repo, Jenkins, you configure Jenkins and get in the GitLab. I keep saying GitHub, or you can also do GitLab as well. But then GitHub is the general famous one that I just want to use as an example. You can configure between GitHub and Jenkins in a way that anytime somebody commits a code, so that's why I mentioned the developers. When they do something on their local computer, when they're done, they have to commit. So commit is kind of like pushing it to the remote repo. So with that one, anytime they commit, GitHub and Jenkins have configurations between each other that Jenkins will automatically find out that something has been committed or something has changed. That's called the automatic polling or automatic pulling. Jenkins will pull the code from GitHub, and do its own automatic building and testing. So that's why the automation comes in place. You're not waiting for no human or any manual person to go grab it and do building and testing. All that in the waterfall scheme used to like waste a bunch of time, and also you're kind of like playing the waiting game. If you were like a tester, you're always waiting for the development guys to be done before you can do something. If you were on the operations team, you always had to make sure the testing guys were done before you can do your job. So that's kind of like why they introduced in a continuous integration, continuous deployment, in the sense that nobody's waiting on nobody to to get stuff done. So that way, back to this process, Jenkins will grab the code, do the automatic building, do the automatic testing. Then when that's done, after you compile and build code, the end result of that code is called an artifact. So that's when the next version on the next tool in DevOps comes into play. The Nexus, the most I guess famous artifactory or artifact storing software is called Nexus. So Jenkins uh, will go and store your artifact in Nexus, or you can also even store it on Jenkins itself. But then um, you don't want a single point of failure when it comes to DevOps. You have to, in case maybe something goes wrong with your Jenkins software or whatever, then you've lost all your artifacts. You don't want to have that happen. So you store it separately somewhere called Nexus Artifactory. So you store your artifacts there. So that's the next step. After you're done building, testing, and storing your artifacts, the next thing you have to do is deploy it to whatever server that whatever production server or maybe staging server that you're using. So this is when the next um, technology come place. In terms of servers, there can be different type of servers that most companies use. Like I said, I'm doing comparison. So previously, most soft companies run their servers on virtual machines, VM, using like VMware or VirtualBox, um, those type of software. That's how servers started. So VMs are the archaic or the legacy systems that um, most companies use, and now you know we've moved forward. VMs are, they kind of occupy space. They need a lot of maintenance. In the summertime, it gets very hot. You need cooling, all that stuff. You need like people actually working in the data centers of these where these virtual machines reside to maintain them. So it gets um, a little hectic, I guess. So the next step, where most the direction that most companies are using now are using cloud technology, which is why AWS plays a game here. So to have my AWS console open, um, the number one, I guess, service that most companies use in terms of virtualization is the EC2 instance or the EC2 service. So I'll click on EC2. So with that one, like I said, I'll do comparison. So I'll open how it was done previously. Then I'll also show you how it's currently done. So with the VMs, like I said, the software that most companies use were VirtualBox, or well, VirtualBox is more like a small project individual. You're doing your try and error thing. Most companies use VMware. That's more enterprise level. So you deploy your artifactory onto your VM, which was done previously. So I have the VM open here. So this is VirtualBox. This is a Linux virtual machine that is installed on the VirtualBox. So this is the server. So this is an example of a server where we will deploy whatever we coded, built, tested, and have it finally as an artifact. We will deploy on the type of virtual machine. But now the virtual machine part has been. I mean, some companies are still using it, but most people are doing cloud technology. In the sense that with cloud technology, it's kind of like pay as you go. You don't have a physical server in your office space, wasting space, or you're not employing people to maintain the data center that these virtual machines run. So you're cutting the operational overhead when it comes to cloud technology, in the sense that you're whatever services that you're subscribing for, you're paying for, you're not seeing them physically, but then you can access them remotely. So that's the cool thing about it. You still own them, or you kind of own them temporarily, because AWS is kind of like a landlord, and you're renting out like an apartment. So for how long you want to rent out that apartment is considered as yours. But then when your lease is up, your landlord can come kick you out. So that's pretty much like how AWS is. AWS can give you all these services. If I click here, um, on the left side, you can see all the services that AWS offers. So if I click all services, when it from A to Z, all the scrolling that I'm doing, you can see AWS is is big, it's heavy in the cloud game. They have pretty much a service that does anything IT related. So all these services, you can rent them, as a tenant, and you can use them, while you're using it. And when you're done, you pretty much you're checking it, you're checking out, you're moving out, and you're giving it back to the owner, which is AWS. So that's I always tell people that's the whole concept of cloud. Cloud is just accessing IT services over the internet. That's all cloud is pretty much. And AWS is the big boy in the game. You have Azure, the runner up. You have Google Cloud. That's probably third. Then you have Oracle Cloud. That's like building its way up into the ranks. I'll consider them as fourth. I guess they even have like Alibaba Cloud and all that stuff. But I've only touched AWS, Azure, a little bit of Google, and Oracle. Let me see. Oh yeah, I see. My screen is covered. Yeah, Kojo, you have your hands up. What's up?
So you mentioned about the cloud technologies like Azure, Google, AWS, and stuff. And I've been in spaces where people are saying that, oh, it's good to learn like other things like Azure, Google, whatever. And I'm like, what's wrong with me focusing on just AWS since I'm now like venturing into the tech world? Would you advise me to just focus on AWS or keep like circling around like other places?
Okay, yeah, that's a pretty good question. So I guess it all depends on the scenario. So if you're trying to get your leg into the door of like the cloud profession, it is definitely always good to specialize first. Like for me, I specialized in AWS first before. In the only I'll say in that scenario, the only place that it makes sense to um learn they call it multi-cloud, learn like multi-cloud technology, is if you're planning on being hired to a company that runs multi-cloud architecture. Like most majority of companies stick to one. Like most will stick to AWS, or most will stick to Azure, depending on whatever they have already, on-prem. So um, originally I'll say it's best to specialize in one, because at the end of the day, whether recruiters are looking for you, or whenever you're applying for jobs, you're gonna be applying for like AWS engineer, AWS cloud engineer, or a recruiter is gonna reach out to you and say, hey, we are looking for an AWS engineer. So like usually, plan A is to just specialize. After you specialized and you feel that you're like comfortable with one platform like AWS, that's when I'll say it's a bonus to venture into other places. Like I'll suggest Azure next, since you're the next powerhouse. That's when is in the scenario for you to, I guess, learn some Azure and try to be like versatile and be multi cloud capable. But then I always advise people to specialize in one. When you're comfortable there and you have time, then you can start looking into other places. So from the jump, I wouldn't suggest to um do a little bit of AWS, do a little bit of Azure. It can get confusing because they're all the same services, but they are named differently, and your brain, you can just kind of like trick your brain and maybe say something Azure based when you're trying to refer to something AWS because you're like multitasking. So yeah, I guess after all my rambling, I'll say stick to one first for sure, then move on to the others. Unless you're another scenario is if you're a consultant. Like for me, for example, I work for a cloud consulting company where you work on stuff based on projects. So project A, for example, the company uses Azure, which is Azure, or the company uses AWS. So you knowing AWS is great for you. But then let's say if you leave that project and they want to put you on another project where it's not AWS and it's Azure based, that's when they would require you to also know Azure. So in terms of consulting, that's when it would be best for you to know multiple, because with consulting companies, they don't really like your boss is not really going to ask you, oh hey, do you know Azure? There's a project that I want to put you on that is using Azure. They usually won't ask you because they're paying you by the goal, so they just expect you. When they say cloud engineer and consulting, they expect you to know multiple. So when it comes to consulting, yes, it will make sense to know multiple. But then if you're just working for an in-house place, like one company that uses one cloud, then it's always good to just specialize. Then, like I said, if you have time, you can just branch into other stuff. So I'll say that's how that will work. Um, so yeah, great question. When it comes to like multi-cloud questions like that. Um, so yeah, I think back to the CI/CD process. I was at the deployment stage. So this deployment stage, I talked about VM. I showed you guys what VM looked like. So EC2 is the next one, which is where EC2 instances is pretty much a VM running on AWS technology, where you can go and like spin up any type of instance. That's how they call it. You can spin up any type of instance, and you can choose whatever operating system that you want. So when I clicked on launch instance on our screen, you're gonna see it's gonna pop up. Um, it's gonna give us a bunch of options for whatever image that we want. So the images are, you know, the operating systems that we want this virtual machine to run on. So here, AWS will give you some of these options. Linux, which is what most IT companies run their servers on. Mac, some companies run stuff on Mac. Windows, most companies run stuff on Windows. So Red Hat is also a type of Linux. So these are all, there's a bunch of um, operating systems that you can run. Debian is also a type of Linux. SUSE Linux. I don't even know how. Like, I've heard people pronounce this differently. SUSE. I've heard people say saucy. It don't matter. I don't use it, but it's a type of Linux. Ubuntu is also another type of Linux. So AWS gives you all this variety of whatever operating system that you want. They have a free tier eligible where you will not pay if you're doing basic stuff, because it's just giving you like basic infrastructure. For example, this is a T2 micro free tier eligible. It will be what it will give you one CPU, 1 gigabyte of memory. Your RAM will probably be like maybe 4 gig, 8 gig. You can tweak it if you want, but then you have to make sure it's still tied in the free tier eligible space. So for here, T2 micro is the only free tier eligible one here. If you choose these other ones, as you can see here, this is how much your landlord AWS is gonna charge you per hour. So yeah, 58 cents per hour, 81 cents per hour. And at initial stage, you might just see this as coins, like, oh, I can pay for that. Oh, 1 cent, just a few change if you're a baller. But then one thing about IT processes is that whatever you're doing or whatever project you're working on, it's not gonna take an hour unless it's just something that you want to do real quick and stop. Usually it will take months, years, or whatever time frame your project is running on. And just imagine being billed these little coins, by the hour for a whole week, a whole month, a whole year. You're gonna go broke for sure. So that's why in the enterprise scheme or in the real workplace, make sure that like whatever resources you're using to do whatever you're doing, and when you're done, you just extinguish it, or you just stop the service. That's pretty much how AWS works. It's pay as you go. For example, maybe like I'll use a military example. You move to California for like a 3 month military deployment or whatever. They give you an apartment there for 3 months. Boom. The landlord gives you the terms and services that, hey, I'm only charging you 3 months of rent, but then the caveat or the deal is that before you're leaving, make sure you come back and give me the keys. Don't don't leave the key on the counter, or don't put the key under the mat or something and think that I'll expect that you've moved out. Like, come and give me the keys to kind of like uh you know establish our contract that you've moved out. That's pretty much like how AWS works. When you're done, stop the service or delete the service or whatever. That's how it works. Or if you don't delete the service and you expect me to think that you deleted it, I'm still gonna charge you for how much long I think you're using it. That's how AWS works. So it's communication, it's accountability. If you make a mistake, you can drain a lot of money if you're not vigilant. So that's how AWS works. So yeah, these are the virtual machines that I mentioned you can deploy stuff to in terms of um, EC2 instances. Another modern technology that most people, because that's how IT works. Something better always comes, and people move on from the old thing. You know how we had pagers, we moved on to big Motorola phones, we moved on to like flip phones, Nokia and stuff, and now we have iPhones and all these new gigs and that stuff. That's how technology works generally. So now we have containerization. So AWS also has a container service. If I go on the left, if I type containers, these are all the four container services that AWS runs. Your ECS, your EKS, which is Kubernetes, is a step above ECS. But then you can choose to deploy this CI/CD process to a container instead of a virtual machine, which is what the VM and EC2 are for. Containers are more lightweight servers. It doesn't use a whole computer's hardware. Like, it's pretty much like lightweight computer that's still that you can run your processes on, and it will take less space. It will take less money. It will take less computer RAM resources and all that stuff. So it's its own technology. So if you don't know too much about containers, I'll say go do your homework on that. I'll just type it probably on Google, and obviously it's gonna give you the literal container thing that us Ghanaians, we're not new to containers. We always ship stuff back home in drums, and these are what they put on the docking ships and take it back home. But then I meant container in a IT sense. If I add IT to the containers, it says a container is a standard unit of software that packages up code and all its dependencies so the application runs quickly and reliably from one computer environment to the other. So this is the how you containerize applications. That's the whole point of containerization. You're containerizing the application, not the operating software or the system or whatever it is. So this is the diagram. This is your infrastructure. So Windows computer, we can use example host operating system. So let's say our Windows computer runs Linux or Windows. That's the second part. Then there is a container software that is standard or widely used in the IT space called Docker. So Docker is the container engine that you can use to containerize whatever application. So you can see all these on in layers. Docker is the third layer, and on top of Docker is when you would containerize your application, and that's when this diagram comes into play. So instead of us having this artifact deployed onto, like previously said, virtual machines, we can containerize this artifact, or the artifact here is the application or the software. Instead of putting it on a virtual machine, we can put it on a container, and that's what we call containerization. And the container is what the Docker software, which is what I mentioned here. So in IT, everything ties down, everything is related to each other, and like I said, new stuff comes about. So that's the third option. We started with a VM, we moved to EC2, which is VM on the cloud, and now the third one is what? Container. With a container, you can run Docker locally on your computer, which is how everybody started, or that's why all this tie into place. You could even run Docker on these VMs right here, because Docker is just a software that you have to install on these VMs. So you can run Docker on a VM, or the latest way to run Docker is just having a Docker server on the cloud, which is how ECS and EKS comes into play. So with ECS, all you have to do is just have your Dockerized application and put it into a registry called ECS, um, Elastic Container Registry. So you can see here, you have your repos, you have all that stuff. This is just a step above what Docker does. AWS wants to cut away all the wahala of managing whatever operating system or whatever server these containers are running on. All you literally have to do is just put your Docker images. That's how Docker works. Docker works as an image. You put your Docker images on ECR, and pretty much AWS does the rest of the stuff for you. It will manage the servers, the networking, the orchestration, all that stuff AWS will do for you, which is what ECS is. EKS is a step above. So we mentioned Docker here. Docker is just the containerization software. You can get to a point where you've had too many containerized applications, and now you kind of have to orchestrate them. You have to let all of them interact with each other, which is where Google came about with what? A software called Kubernetes. I know it sounds weird, but it's some type of some Greek methodology. I don't even know. But Kubernetes provides orchestration to manage all your container resources from a single control plane. Pretty much, I guess there's a diagram here that I can click on. So you have each of your Docker containers, but then to have them interact with each other in terms of networking wise, API wise, to just give you the final results of a software. For example, Instagram. If Instagram is running on Kubernetes, you need to make sure that each of the Instagram servers that does different things can like talk to each other, fault tolerance in the sense that if one goes down, another one can come up automatically. That's what orchestration is all about. It's very complicated stuff, but even me myself, I don't even want to talk about it because every time I talk Kubernetes, I lose some type of brain cells. But it's great because it pays great. Like that's the future of IT now, containerization. So if I say Kubernetes engineer salary, for example, you see the numbers right here. This is the average. 146K. You can move up to, even I feel this is outdated. Now Kubernetes people, I feel like the average is like 150, 200K going up because it's complicated mechanism. So this is the price for losing all those brain cells to understand how Kubernetes work. You're getting paid good money. 70 an hour, great money. It goes up from there. I feel like this scale is kind of outdated. Like people are getting 200K, 300K plus as a Kubernetes engineer. So as complicated as it is, it's very rewarding in the sense that if you can grasp it, and that's something you specialize in when it comes to containerization. You can know it, but then if you really want to get into it, it's something that you specialize in, and that on the team, you're the one contributing to containerization workloads. You're the one orchestrating stuff. You're the one writing Kubernetes manifest files. You're the one writing Docker files to just pretty much containerize what you guys currently have. It's complicated stuff, but hey, like I said, it's rewarding, and that ties down into our container part. You can have it locally on your VM. You can put on the cloud in ECS or EKS. And these are just AWS tied because I'm just mentioning AWS. Azure has its own Kubernetes service, Azure Kubernetes service. Google pretty much invented Kubernetes. So on Google Cloud, they have their own native Kubernetes service. And as time goes on, other, cloud services that come up will start adopting their own names. So that's the final part to deployment. You can deploy to a VM, EC2, a single container, or your Kubernetes workload. Then finally, it comes down to configuration management. You want to deploy stuff to these servers automatically in the sense that you don't want to be doing no type of manual, click, click, click to deploy something. You want to configure stuff and have it deployed automatically. So, which is where the last software, actually not the last software, the last but one software that I'm going to talk about ties in. We call it Ansible. It's a suite of software or tools that enables infrastructure as code. It's open source, but then it can also be enterprise based because it's developed by Red Hat. And Red Hat already are big dogs when it comes to Linux, like enterprise Linux. So it is managed by Red Hat, and pretty much you can deploy stuff to these servers known in the fashion or in the sense as playbooks. So you write Ansible playbooks, and Ansible playbooks pretty much will deploy to each of your servers automatically. So this is like a diagram here. You put all your playbooks on Ansible, then Ansible will push whatever configuration you want to each of the servers. So, example, you have a web server, you have a database server, application server, maybe storage server. All of these are its own remote hosts. But you don't want to go on each of them. You don't want to log on each of them manually and deploy stuff on them. It takes a while to get that going. So the best means is configuration management, where it's kind of like you hit a button and it pushes this configuration to all these hosts automatically as one. It's kind of like killing 10 birds with one stone. That's how Ansible works. So you can use it in that fashion, and it will cut down a lot of operational overhead, a lot of manual work. So that's how Ansible works. I won't get too much into that, but then that's the two that most softwares use for their configuration management. Ansible. Then, as you can see up here, all of this thing that I've talked about today, it can get very, very, very complicated, and it can get very overwhelming. So the best way to kind of have it uniformed and reusable is pretty much to code all of this. So all of this are infrastructure. You code all of it somewhere with a software known as what? Terraform. Or AWS has its own native infrastructure as code software called CloudFormation. But then with the limit or the setback about CloudFormation is that you can only code infrastructure that is residing on AWS, which is why I said CloudFormation is AWS's native infrastructure code tool. So all this, let's say if our source code repo, building and testing agents, artifact, configuration management, all of this was residing on AWS, then we can use CloudFormation. But then if these are like open source tools, or if these reside on different cloud services, then it's best to use Terraform, which is industry standard. Most companies use Terraform. So Terraform, why did I even close that? Let me bring it back up. Where did it go? Okay, I got it right back. So yeah, Terraform is pretty much how they call it. It's universal. I put in parentheses here. You can use Terraform for open source. You can use Terraform for AWS, Azure, Google, any type of cloud infrastructure. You can use Terraform. So with that one, you just code it all in like a HashiCorp, that they call it HashiCorp language, but it's pretty much, if you know what YAML or JSON is, it's kind of like declarative programming languages. So I'll just type Terraform right here and kind of give you guys an image of like what Terraform looks like. So pretty much all this gibberish here is what, like, how you would declare your Terraform infrastructure. So here, off the buck, you see something called resource. What's the resource name? It's an Azure project. This is the name of the project. This is the description. This is the version you want to use. These are the features that you want. So Terraform is what? Infrastructure as code in a declarative way. You're declaring what you want, how you want it, what version that you want it. Let me see other stuff as well. You can declare like variables to use in your code later. Like you can do a whole bunch of stuff with Terraform. I don't want to get too deep into it, but example, this is an AWS database instance. You have the type of instance class, how much storage you want allocated to it. Some of the credentials are listed here. What type of networking phase you want it to go into, like your VPC, availability zone, if it's publicly accessible, if you want to back it up, how long you want to retain the backups, like anything at all is possible with Terraform. So nowadays, I think I mentioned this the other time to you, Kojo. If you know cloud and you don't know infrastructure as code, like it's pretty much useless these days because like most IT places have cloud technology, all right, but they don't do stuff manually. That's when stuff goes bad because if you do stuff manually and in IT there's something called human error and you commit a human error, you're losing company data or company resources, and that could prove very, very, very bad. You're losing money, which is company data. So it's best to code it as your infrastructure as code, in the sense that if anything goes wrong, you have a backup. You can reproduce the whole infrastructure. It can also be reusable. So in terms of in IT, you have what you call a development phase, you have a testing phase, you have a production phase, and all these phases have infrastructure. So development infrastructure is what the development team does their development on. Testing infrastructure is what the testing team does their testing on. And production is the final product where the system is live. So anything that goes on in production, the customers actually see it. For example, if something goes wrong with an Instagram production server, all of us, which are Instagram customers, are gonna see it happen. Sometimes it will happen on Instagram or Twitter where you'll be like, oh, Instagram is down or Twitter is down, blah blah blah. Something is going on with your production server. So that's how that happens. So you want to reproduce you know, the environments, with one click button, so that it can form like uniformity, and you can always have stuff rapidly. You can produce stuff rapidly on the go. For example, if Instagram's for example the production server went down, you have it already coded as an infrastructure as code. You can just spin it up again and pretty much just add your previously owned data to that new infrastructure and pretty much have it going. Or you can always have a backup plan B server somewhere that you can just make the plan B server your primary server. It's like a bunch of orchestration and complicated stuff, but if you got it together, you're always protecting your company's data and resources, which is why infrastructure as code ties all of this down. And that's pretty much the big picture of DevOps. I know I went over a bunch of stuff. While I was doing that, I got the chance to shed light on some of these AWS resources because, like I said, AWS has everything. This whole diagram that we built here, and we talked about each of these individual services. AWS has all those services for people to use, whether development, testing, containerization, database, networking, you name it. AWS has a service that actually does that for you, and it's a pay as you go service. So uh, while learning DevOps is good to learn all these individual open source tools as well, but then the best way is to tie cloud stuff into DevOps and just have both of that experience. So you can really be a cloud engineer without knowing some DevOps you know methodologies, and you can really be a DevOps engineer without knowing some of these cloud tools, because that's what most companies use. So they pretty much go hand in hand, and they pretty much you're tied in together. So yeah, that's pretty much today's workshop. I'm glad I recorded it. I know we covered a bunch of stuff over the little time. So yeah, the time is pretty much up, but I'll probably just use these last 2-3 minutes to ask, if you guys have any questions on or anything that was discussed today.
I do have a few. So, is it possible that can you hear me?
Yeah, I can
Right.
hear you.
Okay, okay. Is it possible that you can create a project where we can incorporate these things, or you can give us like a homework where we can try to incorporate like these building the code, and deploying it and try to see if it works. So for like I think what I've also heard is that when you start doing projects, it also helps with your quote unquote experience. Since I'm now again venturing into the IT world, I wanted to see if we can try to, you know, find some project where we can also like work on it. I don't know if it's a good question to ask.
Yeah, yeah, that's a great question. I guess the first stage was just learn the theory aspect of everything, but yeah, then definitely the next thing you'd want to do is definitely try to do some hands-on on incorporating all these resources and technology as a project. So I can definitely point you to some projects where you can do on your own, which is the beauty of, I mentioned previously, GitLab or GitHub and all that stuff. There's a bunch of like public GitHub repos where they'll pretty much give you like projects to do, and they'll give you pretty much step by step processes of how to do these projects to provide you actually with the code, like to the application where they want you to deploy. And there's pretty much like step by step ways of how to doing it, like how to spin up the resources and all that stuff. So yeah, if you want to definitely try your hands on some projects, I'll look into that, like some of the stuff projects that I probably did personally or use as practice when I was trying to get into the field. So yeah, definitely good for bringing that up. I can go back and find some, and I'll just point you into that direction. So with those ones, all you'd have to do is probably like clone like a GitHub repo to your local one, and it'll give you step by step. Like, okay, this is the code. They'll teach like maybe step by step on how to build a pipeline on Jenkins, or how to spin up whatever service you want to deploy this code on. And yeah, there's a whole bunch of public projects on GitHub that I can point you to that can aid in your hands-on practice. So yeah, I can point you that way.
All
Question.
right, thank you. Okay,
Yeah,
go
go
ahead.
ahead, Rini.
So because you just mentioned how to build a pipeline on Jenkins, because me too, I'm trying to like work on a personal project and then get my experience together since I'm in the job field or I'm in the, you know, searching for job phase.
Right.
Because today I was working on, I didn't finish though because I was so confused. I was trying to build a, what is it called, a serverless data processing pipeline, right? So I
Okay.
was on what is it called, Terraform,
Uh huh.
put
I think your voice is going in and out.
on on Terraform. So now I'm so confused. I don't know how to do it.
Gotcha.
Okay.
Yeah, yeah, that makes sense
Uh,
because with the hands-on stuff, even though there's a lot of do it on your own stuff, you definitely always need some type of direction on how
Yeah.
to get like that going. So yeah, definitely I can try to see if I can, like, whatever you're already working on,
Uh
if
huh.
any way I can help, or I can also point you into something that you can start from scratch that has more. direction, like more step by step direction, instead of just
Yeah.
them expecting you to. Some of these projects just expect you to know stuff already, so it doesn't
Mm-hmm.
help if you're learning like how to do it. So yeah, I'll try to send you like some step by step stuff that
All right.
will help you out. Yeah, for sure.
Renee, if I may ask you, since I'm now taking my solutions architect associate, how was it for you? Like when you were studying, was it difficult? How was the exam? Everything.
Um. Okay. Well, for me, I took it last year November, and for the difficulty, I wouldn't say it's difficult if you've actually like prepared for it, right? And then also, I also used this website that has test questions
Okay,
to
practice test.
practice. So difficulty, I wouldn't say it was difficult because I guess I was well prepared,
Okay.
but yeah, just basically just be well prepared. And then like Kelvin said, like sometimes it has some keywords in there that will kind of like, you
Throw you
know,
off something. Yeah.
help. Yeah.
Okay.
Yeah, that
Okay.
makes sense. Yeah,
Uh,
definitely
uh, okay. Sounds good.
preparation and test. Like I feel like this. And how I knew I was ready to take my AWS cert is when I started getting like 80% on the practice questions. So that's how, because usually the practice questions are harder than the actual like test itself. So if you know
Oh, okay.
you keep on getting like high numbers on the practice questions, that's kind of when you kind of have that confidence, like, oh yeah, like I'm definitely ready to take it. So you would know for sure, depending on the rate of like your studies. It will
Okay.
just let you know, okay, if I'm passing this, then I should be actually trying my hands on the road thing.
Yeah.
Yeah, I guess for me too, the other thing that helped me is also because my husband is a solutions architect. So,
Oh, okay.
questions, I'll just go to him and then just ask him.
Oh, okay. That's nice.
Yeah.
That's
Yeah,
nice.
that's definitely that's what you call personal calculator. That one, you have on your on dispose. So that's great. That's a great resource to
Yeah.
have as well.
Yeah.
Yeah,
Yep.
but
Yep.
yeah, I could always like I said, create like a group chat with you guys as well. Just to some days I do go to the office, or some days I might not be available
Yeah.
for like audio conversation. I can just get stuff going in the chat and
Yeah.
what you call it. Yeah, so
Yeah.
yeah, we can pick up from there. But yeah, I'll try to. Some days I work on the weekends because I'm on call. This weekend I'm not on call, but the weekends that I'm not on call, I can try to get some of these sessions going and just like move on from there.
Yes, please,
Okay.
because uh, I'm struggling.
No worries, no.
But Kels, why is it like that? I don't understand. Because I don't know. I was even applying for like entry level B, like
Right,
something to just start in, and they go like, oh, have experience in this. This is that security clearance. I'm like,
right.
I'm literally just branching into your field. You're
Yeah,
asking me for all of these things. Why is it
yeah.
like that? I
I've
really want
I've
to know. Like,
I've
maintenance
definitely
here
faced all
is
these
so
difficulties.
frustrated.
Well, what I can say is that um, when it comes to like the IT field, like the modern IT field, like you pretty much have to. Well, how what's the way I can put this? You can't be too honest when it comes to the IT field these days.
Yeah,
Whatever.
that's what I'm learning the hard way because
Yeah,
Yeah,
I'm like, so we have to lie on the resume, like we have
pretty
to.
much. Yeah, technically
Oh
you're
God!
pretty much lying, but then it's kind of like they've given you like a picture to like emulate. You pretty much have to like draw the same picture you're expecting. Like you can leave some stuff out and be like, oh yeah,
That's
like I
so
haven't done this, but I plan on adding this part to the picture later. You pretty much have to present yourself as tip
some
top, even though
yeah.
you know in deep down that you're not tip top. You have to sell yourself as tip top because now like the concept of entry level does not exist anymore. Like they expect you to
wow,
know something, which is where you
wow.
have to pretty much lie and be like, yeah, I
Yeah,
know this.
literally lie
Yeah, like pretty
because
much
Kels,
lie and
Kels,
say you know it.
I've heard recruiters telling me that if you lie on the on your resume, like you are easily to be blackballed, like literally.
Recruiters
You
are
feel
the
me?
worst the worst people ever. Like don't
Oh
listen to
my gosh.
no recruiter. At the end of the day, the recruiter they've given them a budget. Let's say a
Yeah.
budget of like 100,000. The job of the recruiter is to at least try to get something to take maybe
Yeah.
60,000 or 70,000 of the overall budget. So
Yeah.
recruiters are not the most honest people because at the end of the day, their job is pretty much is to kind of finesse you low key to take lesser
Yeah.
than the budget. So don't listen
Yeah.
to any type of recruiter at all because at the end of the day, when you get hired, they're getting a bonus. So they
Yeah.
don't recruiters are kind of like HR. They're low key fake. Like no offense to recruiters, but it's part of the job. Like don't ever like get personally tied with
Yeah.
any unless you know unless the recruiter is your own friend, then that
Yeah.
one they'll probably be more honest with you. But if it's a random recruiter, they don't care about you for real for real.
Right.
Recruiters don't even eat into don't waste your time feed it into them.
And also, Kels, right? I don't know if Renee has also can testify to this. I think is you're just one of the few people who kind of like creates a community like this to help other people because it's crazy. People have like 3 or 4 jobs in the IT field and you're asking them, "Oh, how did you get into it?" And they want to just like get keep you. I don't know why. Like it's just I mean, I see a lot of videos saying that oh, there are tons of jobs out there, tons of job here and there, but like none of them is saying that oh, Charlie, I've heard this thing, so you come do it. Like none, and it's
that
crazy. It's just
that does make
it's
a lot of
crazy to
sense.
me. It's crazy to
With
me.
that, I guess with that one, it usually ties into African culture or
It
for
does. It does.
us directly like
It does.
Ghanaian culture. Like I guess
Mm.
there's a stigma where Ghanaians like to show off or one up
Yeah.
the next person. Like, oh yeah, I have
Yeah.
like two, three jobs or whatever. Not acting like I'm better than you, but like it's hard for somebody to show you the blueprint of how they got to what you're doing because they low key don't want you to get to the like the stage that they're at.
It doesn't make
Or
sense. It
yes,
doesn't make
it's
sense.
unfortunate,
Like
but that's how it works.
someone told me, say, Kojo, if I show you the blueprint, you are taking the job from me. I'm like, when you have 3 or 4 jobs, how am I gonna take 3 or 4 jobs from you? When you just like I was so messed up that day. I was like, what? I
That's
just need an entry. Anyway, Renee, what's the thing? Go ahead,
men.
please.
They say I don't know any Ghanaians.
Oh, yo, it's crazy, yo. It's
I
really
don't know
crazy. It's
them,
very
so like,
sad.
Calvin is the
It's
only
very
person
sad.
that actually does cloud engineer stuff. That's why I came to him to ask him for help. Besides that, too, I guess because we've been friends for so long, that's why. If not, I
Oh, okay.
don't go to
Okay.
Ghanaian for anything.
Man,
Yeah,
sad, man.
I actually
Sad.
just got a work call about something,
Okay.
so yeah, I'm going
Okay.
to. I'm gonna get the recording out if you guys want to refer it to it
Okay.
later.
Yes,
But then,
yes.
like, I'll
Yeah, yeah,
create a
yeah,
group
yeah.
chat between all of us, and we can just move on from
All
there.
All
right.
right.
So yeah,
Take care. Take
yeah,
care.
appreciate you guys for joining today. We'll talk.
You're welcome, man.
All right.
Bye.
All right. Bye.